Okay, I know I'm belting through this. It's because I only need you to know a little bit about correlation. But I thought it might be instructive for you to look at this. This is SPSS, which is the statistical package for social sciences, and it is one of the more common statistical packages used. What's annoying about it is instead of a p-value, they call it a sig. So if you look here, and these are some of the variables of things that we collected from you, and you can see they've got little stars. Anything with 2 stars is correlated significant at 0.01 level. Okay, so here we've got a correlation of 0.488, which is significant at the 0.01 level because it's got a significance level of 0.0000. And what that's saying is there was a correlation between the average income for the class in 10 years' time and what they thought they would be earning. So there's a moderate correlation between what people think they will be earning in 10 years' time and what they think the rest of the class will be earning in 10 years' time, which is not that surprising. And if you can look down here, there's one here. This is not correlated. So you've got how many texts did you send yesterday? If you're earning a lot of money, what's the most you'd be prepared to pay for a car? So no relationship whatsoever, which is not that shocking, really. So these correlation tables are really quite handy when you get a whole mass of data and you want to see what sort of relationships are there. You do this correlation thing, and so you've actually got 1, 2, 3, 4, 5, 6, 7, 8, 10 correlations here. It's symmetrical, so you don't worry about the other half. And that helps you to see what's actually going on in the data. So when I was deciding which examples to use in class from this data, I did one of these first so I could look at it and see how things were related. Now, when did that happen? Oh, sorry. Sorry. There we go. Panic. I thought, oh no, I haven't had a screen for so long. Yep. Okay, now this thing here is real. It's just my own little invention because the p-value is related to 2 things, the actual correlation and the sample size. Now, the bigger the sample size, the smaller the correlation can be and still be significant. And this is a really important concept, is this concept of effect size and significance. Now, this green shaded bit, all of the values here are less than 0.05. I've just got a cut off there. So what I'm saying is that, so anything green is a statistically significant result, which means that we have evidence that it exists in the population from the sample. If we have a sample size of 10, and we have a correlation of 0.6, that is not statistically significant because we've got such a small sample. But if we have a sample size of 1,000 and we have a correlation of 0.6, that's got a p-value of 0. And in fact, even a correlation of 0.07, which is a teeny little correlation, is still significant if our sample size is 1,000. So what it's saying is that if your sample size is really big, even very small effects can be statistically significant. It's not about what percentage of the population it is, it's about the sample size. Okay, so more about this next lecture, but what I want to get in today, now I've hurried too much, groan. Okay, so you've got this idea of strength, significance, causation, and association. Okay, so a strong effect is one that explains much of the variation. So that would be, in here, strong correlation is anything sort of from 0.7 upwards. We're saying there's a very strong effect. We're saying, if say the height of mothers and sons was correlated at 0.7, we would say that, and in fact if you square that 0.7 it comes to 0.49, which is pretty close to 50. So 50% of the variation in a boy's height can be explained by the height of the mother. So when we're talking about strength, we're talking about how much of the variation it is explaining, or the dots are close to the line. Now the next word is significance, and one of the problems is that the word significance in everyday life means important and worthwhile. In statistics it does not mean important and worthwhile. It means that we have evidence that it exists in the population. It means that the number is less than the p-value is less than the significance level. So a significant level is one with a low p-value. We have evidence that it exists in the population. Okay, so that's the next idea. Causation. Causation is when we say something causes something else. Smoking causes cancer. That's a thing that people have spent many, many thousands of millions of dollars trying to prove is false. And true, whatever, depending on who's actually paying for your research. Or that drinking alcohol causes accidents. Now, if you just collect data on all of the people who are in car accidents and find out if they were drunk or not, all it shows, and you see there is a relationship between them, it shows that people who are in car accidents are more likely to be drunk or whatever. But it could be because most accidents happen at night and people tend to drink at night. So you have to be very, very careful about proving causation. To prove that drunk driving causes accidents, what they do is what they have done is that they actually get people drunk and see what their reaction time is and things like that. So they have proved causation through controlled experiments. So generally you can't prove something causes something else. Another thing is a lot of things increase all the time, like the crime rate is going up and so is the population. But we don't say that the crime rate is causing the population to go up, nor do we say that the population going up is causing the crime rate, because it may well be something else completely different. Simply because two things are increasing at the same time doesn't mean that they are necessarily causing one another. So generally to conclude causation we need a controlled experiment. And association is in fact what we can claim. We can say that an increase in this is associated with that, but we cannot say that one causes the other one. Okay, lots of meaty stuff in this lecture, lots to think about, and we'll finish off Module 6 next Thursday.